Hello everyone, welcome back. Now we'll be proving some of the theorems here, and this is a very fundamental theorem, and it is so simple to prove. So if you have not done this problem before, and if you are seeing this type of solutions for the first time, then you will be surprised to see such a simple solution to these kind of problems. So without further ado, let's start to do this solution here. So we have to prove that two parallelograms. So there are two parallelograms, Rmn q and Pmn o. That means this Mn is common on both sides, right? So both parallelograms. So let's draw two parallelograms here. Okay. Let me name these things as R, M, N, and Q. And the other parallelogram is PMNO. So this Mn is the common base. So let's say this PMNO, right? So these are two parallel and standing on the same base Mn, and between the same parallel lines Mn and Ro. Yes, the parallel lines are, so this and this is parallel, right? So there are two parallelograms. So one of these is this one, the other one is this one, right? So the construction is done. So you'll get 1 marks for this construction. So construction is done here. All right. Now another construction you have to do is draw one height. All right. So Mn is the base, and if you draw a perpendicular from this parallel line, so you can draw it from any point on this parallel line Ro to Mn. You can draw it from here, right? You can draw it from here, you can draw it from here. The length will be same, right? Even if you extend it, and you can draw it here, right? So this will be the height. That means the perpendicular distance between these two parallel lines, all of these will be equal. So you can draw it anywhere, because that is the property of parallel lines. So these two parallel lines are separated by the same distance, but we have to measure it perpendicular. All right, so the distance will be same. So based on this simple theorem, or the property of parallel lines, we can say that this height, no matter which point we take, this will be the same, or between these two parallel lines Ro and Mn. And so let me just draw it here. So OM is the height. OM is perpendicular to MN, right? So don't write it. Let's write it what we say OA, because M is the other point, right? So OA is perpendicular to MN, and OA is the height of parallelogram. Height of parallelogram. So now following our usual technique of statement and reasons. So the first statement we have is area of parallelogram R, M, and Q. So area of this parallelogram will be equal to half. Base is Mn, right? Base of this parallelogram is Mn, and sorry, not half. Parallelogram area is not half. Area of triangle is half. So area of parallelogram is base times height, right? So Mn times height is OA, right? We just draw this perpendicular. So OA is the height of parallelogram. And we can write the reason here. Area of parallelogram, right? is equal to base times height. And second statement, area of parallelogram PMNO, right, is also equal to the base is same MN and height is also same, right, OA. Second, same reason as above, or you can write the same statement here. Third, therefore area of parallelogram R, M and Q is equal to area of parallelogram P, M and O, because both of these are the same value, right, from 1 and 2. That's it. Very simple, right? Great. Good luck.